Great. Maybe you don't, or maybe you've never even done it before. Maybe you were asleep that week.
Would you recommend I dig up my last semester's recycling bin because, like, I have all these notes?
So here's the deal. I'll pretend that it doesn't hurt my feelings that you threw my notes out. We're going to take every note you need. We're going to take every note you need. It would never hurt to have more practice, but we're going to take all the notes. Okay? So when we talk about sine and cosine, we were talking about what kind of shape? Fine. Good. So the natural progression, we've been talking about units and converting units. Hey, do you think I'm going to give you some questions by the end of this sheet where it's like this side is 3 feet 2 inches, that side is 1 foot 8 inches? Tell me how long the third side is. Yeah. And one where it's like this is 3 centimeters, that's 22 millimeters. What's the third side? Yeah, I'm going to do that. That's true. But before I do, I want to go back through Sine Law. I want to take another moment too. I'm not going back through SOHCAHTOA, right angle trig. You are welcome to use right angle trig anytime you find it appropriate. But by the time we're done the course, there's no question that you can do with right angle trig that you can't also do with sine law and cosine law. And so to my way of thinking, why give you 3 ways to answer a question when I can give you 2 to choose from? Does that make sense? If part of the challenge of doing a question is figuring out what method to use, I don't see how giving you more choices makes that easier. Does that make sense? But if you're like, no, I loved my SOHCAHTOA questions, and you come across a question with a right angle triangle, go nuts, you. Dig in. So with no further ado, oh, I am recording. Good. With no further ado, let's get going. So today we're going to review, and this should be straight review from grade 11, the sine law. Hands up if you're like, I remember the sine law, know exactly what to do with it. Show off. Hands up if you're like, I've heard of that before. Hands up if you're like, I slept a lot in grade 11. Ah, the truth comes out. All right, that's fine. We're going to get you there today. So we're going to go through and work on using the sine law to evaluate unknown information from a triangle. But before we can do that, I just want to go through just kind of a boring thing of labeling a triangle in trigonometry, because you've probably had a few different things thrown at you. In other words, at some point in your career, they probably would have called this side AC, right? And they would have called this side, and there's nothing wrong with that, but I don't want to use it. And at some point in your career, you probably spent a lot of time being told, tell me which side's the opposite, which is the hypotenuse, and which is the adjacent. And there's nothing wrong with that, but we're not going to do that either. All right? For sine law and cosine law, we just label the triangles such that every side has a 1-letter name, and every angle has a 1-letter name. That makes sense? And if you look, we name angles with capital letters, and we name sides with lowercase letters. So I have already named the angles in this triangle. I called this angle A, called this angle B, and I called this angle C. I could have picked any letters I wanted. Why do we pick A, B, C? Yeah, it's just the letters of the alphabet, right? There's no proof that I know my alphabet past H. So, you know, here we go. It doesn't stretch me beyond what I know. So now, how do I name the sides? And if you think, if I want to label a side with only 1 letter, this side touches angle A and it touches angle C. And this side touches angle A and it touches angle B. So what did they come up with as a way to name them so that it's not ambiguous, so that's really clear, so there's only one way to get the names? Very good. And the way I think of it is, like, it's the angle it doesn't touch. This side here, what angle doesn't it touch? It doesn't touch B. So we're going to call it side B, and sides always get labeled lowercase. With that in mind, what will this side be called? C. And again, C is not always easy as C, but that's a lowercase c, right? And this side over here, A is correct. Anyone have any questions about that? You've done that before, yeah? That rings a bell? I hope. Yeah.
No, I'm looking at the other one.
Good. I want everyone to look at the next one. Oh, that's embarrassing. That should be an R. Wow, who made this note? Slacker. Slacker. I, of course, was testing you to see if you would notice that was impossible. Yeah, testing you. And I'm proud to say you passed. Yes, well done. Okay. All right, so take a minute, label both sides. I'll come around and say encouraging things. Like, good job. Or, that's not right. That's not right. Oh, beautiful. Beautiful. Yeah. Oh, did you?
Yeah.
Same idea. That should say R.
Okay.
Is that the right one?
Yeah.
Perfect.
No. It's just a pencil case of nothing.
You know what? Listen, it could be all pencil crayons. Nobody likes to write a whole lot of pencil crayons.
Oh, my goodness. Different pencil case.
Yeah. Perfect. Yeah. Perfect. Good. Okay. So, it seems like nobody had any trouble labeling these. Kira Shannon, what would I call this side? Very good. Uppercase or lowercase? Very good. What would I call this side? Sorry? Yar. That's right. And down here? P. Very good. Okay, any questions about that? All right. Oh, I really hate splitting my time between two rooms. Those over. I'm going to grab your rulers, and then once you have them, you're going to measure these sides. And I'm going to grab your protractors, and then you're going to measure the angles. Good.
Oh, joy. Oh, this is not that long ago. Last semester.
Grab a ruler, or pass them along or whatever. Get measuring the sides. Right back to protractor. Yes.
Give me a I have a question going back here. Again, like that's a lot of inches, unless that's 5 foot.
No, it's 101 inches.
What's the 5? What's the 5 that triangle?
Oh, no, it's. Oh, that is a big one. You can do it.
How?
It's a challenge one.
That's like way up.
That's a challenging one on that.
What challenge on what?
The 5,101.
Yeah, it's going to be challenged once in a while.
Not there.
Not fair. Oh, I put one. Oh, I was going to say, I put one tricky question on a sheet. It's not fair. Ooh, I should probably measure these on the paper, not on my screen. Otherwise, I won't get the right numbers.
Wait, is it? Well, okay, for the angles, never mind.
Yeah, so we're going to measure the sides, and we're going to measure the angles. Yeah, give me one decimal place is plenty, but give me a decimal place, please. Excuse me, I'm sorry.
You went on your coffee?
I did not, but don't feel bad. I never win.
Why?
Because I am a, what's the word for somebody who doesn't win a lot? Loser. That's it. Bless you. Can I interject? I've done triangle ABC. How are these numbers looking? Comparable? Does anyone have anything radically different? If we're off a decimal place here or a decimal place there, that shouldn't matter. But is anyone like crazy different? Or I'm like, no, totally disagree. We're okay?
Sure.
No, you can tell me. What, do you have one different?
No, I just didn't fill in the blanks.
Well, okay, that's fine. But
I just got 1 degree.
on which one?
Angle B and C.
B and C, you said 40 and 110?
Yes.
Cool. Yeah, don't worry about these two columns down here yet. We'll do those together. Right now, I just want sides and angles. I mean, if you've already done it, you're cool. You're ahead of the game. Like, don't let me stop you. Who am I? Just like a guy in a dress shirt. Shannon Spirinello not here?
Volleyball, maybe. No. Oh, yeah. No, she's not here.
Okay.
No, she was here. Now.
I'll try not to be offended.
You should be. There.
Can I ask for these three angles? I'm stuck here now because my battery's almost dead and I didn't bring a protractor with me. What did we get for angle P?
I got 40.
40 degrees? Did we get anything different?
41.
Yeah, I got 41. I got 40?
I got 40.
Okay, I'm going to put 40, but you know, like if you're 1 degree off, I think we're cool. We got 70 for here. And if you got 40 and 70, then you got 40 again, right? Wait a minute.
78.
That doesn't work.
Are you mad?
That doesn't work. 40 and 70 is 110, so that would be 70 again. Is that what we got? Nice. That looks good. And again, if some of those are one more, one less, that's fine. Okay. So can we pause here with this setup? One of the things that I always like to drive home, and different teachers teach this differently, and I get it. But to my way of thinking, there's a really fundamental question, which is like, what the heck does it mean to talk about the sine of an angle, or the cosine of an angle, or the tangent of an angle? Like, that sounds like pretty obscure stuff, right? And we say these words and like, what's the sine of this? And then if you're like me, you take your calculator out and you press the sine button, then you push a number and then you press enter and it gives you a number, right? And you go, oh, good, I got the number. And you write the number down and we go, good, I'm good at math. But what we mean is I'm good at punching a number into a calculator, pressing equals, and it spits a number out at me, right? What is sine? What is cosine? What is tangent? What do those words mean? Don't you know? Because it's kind of a weird way of thinking. The sine of an angle basically says this. One of the ways we can change an angle in a triangle is by changing how long all of the sides are. Does that make sense? So sine is a way of defining an angle by not actually looking at the angle, but just by measuring all the sides. Does that make sense? Every angle, especially between 0 and 90, can be measured in degrees, right? By the way, what is a degree? Like, what does that mean? What's a degree? Like, we know all this stuff. What is like this angle in degrees? 90. We all know that. What's it mean? What's an angle if it's perfectly flat? Like, boom, like that. Or if I turn all the way around, how many degrees is that? 180. What if I do a complete circle? Why do we know this? Like, what do those numbers mean? Do you want to know what a degree is? A degree is somebody said, okay, if we're talking about angles, let's take a whole circle and let's cut it into pieces. And then somebody said, well, how many pieces? And they said, about 360. And that's what they did. They took a whole circle and they cut it into 360 even slices, and they called every one of those slices a degree. Is that a smart number to have picked? I don't know. Kind of weird. They're not nice numbers, are they? 90, 180, 270, 360. These are weird numbers, right? I guess it sounds cool if you're like into skateboarding, you'd be like, I can do 1080. Maybe you like on that sentence with like a bra or something. And do 1080 bra. But like in terms of actual numbers, they're kind of weird, right? So I gave you a chart. Now, it's not my expectation that you're always going to use this chart, okay? We're going to use our calculators. But I just want to show you this. And I want to make sure everyone's paying attention right now. For any angle that you can measure in degrees, you can also measure the sine of that angle. That make sense? Or the cosine of that angle, or the tangent of that angle. And they're always unique. Every angle between 0 and 90 degrees also has a unique sine, also has a unique cosine, also has a unique tangent. The thing, angles in degrees are nicer numbers, right? These are ugly numbers. The difference is this. I can use these to figure out how long the sides of a triangle are, because sine is defined as a ratio of a bunch of the sides. Cosine is defined as a different ratio of a bunch of the sides. And tangent is defined as yet a different ratio of a bunch of the sides. So if I use these numbers, I can figure other stuff about the triangle out. Whereas if I use this angle in degrees, it's nice to look at, they're nice round numbers, but it doesn't tell me anything. Does that make sense? So I always do this. For the first few days I teach trig, I don't use the calculator to look up angles. I use the table. That may seem a little goofy, but it helps in my mind solidify the fact that like if an angle's 5 degrees, it has a sine of 0.087, it has a cosine of 0.996, and its tangent is 0.087. It helps me know that those are just 4 different ways of talking about the same angle. Does that make sense? So, with that in mind, what are the angles we need to look up? Can somebody look up for me 28 degrees. We want the sine, which is the first column, of 28 degrees. It is 0.469. And we can work together here. We can be a team. If I write here, somebody can look them up. What's the sine of 41 degrees? Should be right near the bottom of the left side. 0.656. And near the bottom, 111 admittedly isn't on there. So we're going to have to use our calculator for that. What do we get?
Do you round? No, I just have a question. Do you round with these, or do you have to keep the numbers?
We're going to round to 3 decimal places for this. That's plenty for what we're doing. It depends on what you're doing. If you were building like a nuclear missile, you're going to want to keep a lot of decimals to make sure everything you make is perfectly precise. If you're building like a house and you're studding the walls, a couple of decimal places is plenty, right? It's all going to be stuck behind the drywall. No one's going to see it. So it depends on what you're doing. This one you'll have to do in your calculator. So can somebody press sine 111 and see what we get there? What'd you get? 0.934? Cool. And back to the table. What's 40 give us? 643. And 70? 940. And this is obviously also 940, right? Okay. Why are we doing this? Do I just hate you? I mean, maybe, but that's not why we're doing this. I want to show you something. Now, if we pick any side angle pair, so here I've got side A and angle A, right? I want to divide how long the side is by the sine of the angle. So what numbers am I going to punch into my calculator here? Yep. Divide by what? Very good. And that should give me a number, 9.16. Okay, there it is. I'm just going to call that 9. We're just going to round to the whole number here because we've measured this with like cheap plastic rulers and cheap plastic protractors, right? So do we trust ourselves to have lots of decimal places here? No, we're just going to go the whole number. What should I punch into my calculator for this one? And what do we get? 9. And for this last one, I'm nervous about this one. This one always gives me trouble. It never seems to work out exactly, but that's okay. What am I putting in?
8.5 divided by 0.934.
And lo and behold, what do I get? 9. This is the foundation of the sine law. If you take a triangle and you measure its side, and you measure the angle across from it in sine. If you take the sine of the angle across from it, that will be the exact same number for all 3 angle side pairs. Does that make sense? Kind of weird to say out loud, but physically for any triangle, if I measure this side and then measure this angle and divide the 2 numbers, I'm going to get the same number no matter which angle and side I pick. But it only works if we measure the angle in terms of its sine. That's why it's called the sine law. That makes sense? That's where it comes from. Let's see if this one works for us too. Now we're talking about triangle PQR. What would I want to punch into my calculator for side P divided by angle P? What am I punching in here? Which is what? We've looked it up. It is very good. And that will give us 8. Right, again, we're just going to round it. What should I punch into my calculator for this one, for side Q, over angle Q?
7.5 sine of 70.
Yeah, which is what? Oh, I've got it up here for you.
7.5 divided by sine of 70. And 0.92.
Yep, Perfect. And then if we actually do that, we get 7.97, and that of course rounds to 8. And again, why aren't these perfect? They're not perfect because we're measuring them with cheap plastic measuring tools, right? If you made these same triangles and measured them with like shop level 1,000th of an inch micrometers, you'd get good accurate answers. And this last one, we're going to get, I measured slightly differently, so I'm going to get a slightly different answer, but still rounds to 8. Does that make sense? So that is a physical proof of the sine law. Now, are we ever going to do that again? No. Am I ever going to ask you to do that for a triangle? No. But I think sometimes it helps to be able to think, what does this rule tell me? It tells me if I take a side and divide it by the angle, that's going to be the same, no matter which side angle pair I pick. And when we say side and angle, we're talking about the angle that controls how big that side is. You ever stop to think about that? What determines how long this side is? Well, if I wanted that side to be 0, nothing, what would I make the angle? 0, right? If I made the angle across from it, nothing, that side won't be there. And then as the angle gets bigger and bigger, what happens to the side? It gets longer and longer, right? That's what the sine law tells us. All it's telling us is how big an angle is depends on, or how big a side is, depends on how big the angle across from it is. If I make the angle across from it bigger, the side will get bigger. If I make the angle smaller, the side across from it will get smaller, shorter. Does that kind of make sense? Okay. That's all the bit we'll never do again, but I think it's good to talk about it. Now we'll talk about the bit we'll do lots, which is the actual sine law. And the actual sine law is nice and easy. It's just this. For any triangle, ABC, this is true. The length of side A divided by the sine of angle A, that's that division, right? And we said it should be the same no matter which side we pick. What's the mathematical symbol for the same as? Equals. And how could I do this for a different pair? Instead of doing A and sine A, I could do B with what would go down here. Very good. And we said that should be the same for all 3 angles. So again, I need the symbol for the same as. What's that symbol for the same as again? Very good. And how would I say this is true for the 3rd pair as well? Very good. Very good. So that's the sine law. And we just kind of came up with that by talking about it. I mean, I coaxed you along the way, obviously, because that's what I get paid to do. But that's the sine law. By the way, that's for triangle ABC. Let's say I had triangle, oh, I don't know, SQL. It's the same, just different letters, right? Hey, how would we label these sides? What would this side be called? What would this side be called? And this side would be S. I'm going to make this like a cursive L so it doesn't look like a 1. And what would the sine law for this triangle be? Yeah? Yeah. Very good. That's great. Very good. Any questions about that? That makes sense, right? So I just mentioned that to say, like, do the letters matter? They don't matter one bit. Doesn't matter what they are. Often teachers are lazy, right? So we tend to go back to the same letter combos all the time. Where we'll make a triangle and it's ABC. And the next question we make one that's like XYZ. And then the next one we go back to ABC. And maybe if we're feeling really bold, we make one DEF. But like the letters are just, yeah, don't matter. Okay. So let's actually try and use this to solve some information. Yeah.
You go first.
Of course.
Does it have to be in like that exact order? The L?
No, it makes no difference. So if you had said S over sine S equals L over sine L equals Q over sine Q, just as right. Yeah, the order could not matter less. And in fact, we're going to talk about that. When we go to solve a question, put them in the order that's useful for you.
You have to use A, B, and C or it doesn't work.
That's true. Actually, we always I try to make them just Mr. Calford's initials. What's your middle name again?
Allen.
There you go. So
Before Tim Allen was famous. I was there.
nice. So TAC.
He was
that's-
selling drugs in jail.
I like Calvin's Daily Poppins. Maybe I should invade his. Maybe we should invade his class one day. We should all learn a flash. You know they do those flash mobs. You ever see that? When you're just sitting in the mall, and all of a sudden everyone stands up and starts singing the Hallelujah chorus.
Yeah.
We should learn that, and we can just invade Calvin's class, sing a song, and leave. Yeah. We could do something from Les Mis. How do we all feel about that? One more day. No, not a Les Mis film. Oh, sorry. Yes.
Go ahead. Oh, did you not have your hand up?
What do you got?
No, I just have a question. Are we not convert this to centimeters or something?
Not in this one.
So later on,
Wait, so I measured it in centimeters now.
Oh, you can't actually measure it. This is just a drawing.
Okay, so
Just a
we
drawing.
can't.
Just a drawing. Yeah, we gotta do the math. Good question, but
I don't
yeah.
like this answer, but
You don't like this
I
answer?
don't like it. It's too big.
I'm sorry.
I use on both calculators, so I'm like, it's correct, but
Well,
it's
we might want to check, is your calculator set to degrees or radians? We're going to talk about that right now. They could both be. Okay, so before we get going, I do want to check one thing, which is if you on your calculator could, and you want to see what Mr. Kelford sent me last night? That's not the right color, and I'm sorry about that. But other than that, huh?
anyone calculator.
Why there's two of them, I don't know. Oh, because I opened it twice. It's the same calculator you guys use. So I can show you. So I want you to do this. Do you see this mode button? The mode button, maybe, do you want to turn the lights off? Like the ones up front? It might help. When we do trigonometry, there's an awkward addition, which is there's two ways to measure angles outside of sine, cosine, tan. One is called degrees, which you know about. Another is called radians, which you're never going to learn about unless you become a physicist. Is anyone planning on becoming a physicist?
No.
All right. Then you're never going to learn about it. So I want you to press mode, and I want you to go down and make sure. You see how this says radians right now? I don't want it to say radians. I want it to say degrees. So go over and press enter. So I should have shown with the actual buttons on here, I guess. Go down to here, over, and press enter. Has everyone done that? Isn't this cool? I think it's cool. And then when you're done that, you can press quit, which to get quit, we press the second function button, and then the mode button again. Oh, does the clear button work?
Yeah.
I did not know that. Now I've learned something. Okay, so let's talk about this triangle right here. So I want to find the length of the unknown side what? What did I ask for? I asked for A. Okay. So how could I set this up? What could I? Hopefully I have a bit of battery here. I want to walk around.
Sine over sine A equals
Okay, whoa, Speedy Gonzalez. Okay, all right, you're not wrong, but let's take it down. First, let's label this triangle. I went ahead and called this A. Did I put it in the right place?
yeah, Gucci.
Okay, what would we call this side? What do you think? What do you think? Yeah, you got it. Very good. And what would I call this 12-meter side? Shannon? Very good. All right. Now, what is the law of sines? What's the sine law for this triangle then? Well, it's always, we said, A over sine A equals what? B over, not yet, over sine B equals over. Yeah, very good. But of course, when we go to actually do this, we need to put numbers in, right? But before we even do that, what thing do we actually want to learn from this? What am I looking for? Yeah, so I'm looking for this. So let's keep that in mind. As we go to fill this out, obviously this is still going to be A because I don't know it, right? But this down here is sine A. Do I know A? Do I know angle A? What is it? Good. And do I know B? What's B? Over? The sine of 99. Good. And then, do I know C? No. And I could figure it out, but I don't yet know C, do I? Like angle C. And for the purpose of this, let me ask you. Jumping back into grade 9 and 10 math, how am I going to solve this? Sorry, I know exactly what you're going to say, but what I'm actually interested in this question is for A. So does anyone know what mathematical technique I could use to solve for A here? Good, good, good. So cross multiplying, right? So we're going to cross multiply. And is that a phrase that sounds familiar to everyone? They've all done cross multiplying before? Because we'll do some practice now. But we're going to cross multiply. How many fractions do you use when you cross multiply? 2. How many fractions do we have here? So what do I have to do with one of them? I have to get rid of it, right? Does that make sense? You're only ever using 2 of the fractions. In this case, which fraction do I obviously not care about? Very good. So this one doesn't matter for this question. I could figure it out. Like, you're totally right. You were going to say what to find angle C? Beautiful. And so you would have got, oh gosh, what'd you get? 38. Good. And that's totally right. But I'm just going to say, do we need it for this question? No. So it's good practice, like by all means. But these are the 2 we want. And once we have these, I have A over sine 43. Actually, let's look this up right now. Well, no, let's not. I lied. A over sine 43 equals 12 over sine 99. How does cross multiplying work? Maybe you've all been taught it different ways. How do I cross multiply this? Yeah.
Sine 43 multiplied by 12.
Okay.
You could do, I don't know if you want it.
Yeah, no, we'll do the whole thing. That's fine.
Divided by sine.
Good. Okay. So different teachers teach it differently, and there's lots of different reasons to do that. In this one, can I tell you how I always do it? We're always going to put in front what we're looking for. So in this case, A equals. And then we are going to pick the diagonal pair that doesn't include our letter. And what do we do with those 2? We multiply by them. And then what do we do with the number that's left over? We divide by it. Does that make sense? That's it. That's all you have to do. Now, how do you punch this into your calculator? Well, I just so happen to have calculator. Let me turn it on. Oh. Is it failing me? All right, I might have to load it again. I was so excited about my calculator. What happened? All right, you might be on your own. I have to tell Calford I want my money back. It didn't work.
It was for free.
Well, hey, here we go. Okay. Okay, so what numbers do I want to put in here? I want to say sine 43, and then what do I want to make sure I remember to do? Yeah, I want to close that bracket. Then what should I do? Multiplied by 12, and then I'm going to divide by 99. And I'm probably going to get the wrong answer here because what did I forget to do when I turned this back on?
Oh, change it back.
Yeah, so let's see if it remembered or not. I might get a different answer than all of you, and I'll have to fix it. Let's take a look. Is that what you got? Oh, so it must have remembered. Let's see. Yeah, it stayed in degrees. Good. Great. So what does A, what does A equal? A equals, good. And I want to round to just one decimal place. So we will say, is that 2 going to stay a 2 or round up? Good. How'd you know that? Good. Yeah, 28 is closer to 30 than it is to 20, right? Good. So 8.3. And what was the unit on this one? Anyone remember? Did I say? Meters. Good. Any questions about that? All right. Try the one next to it.
What are you solving for?
A again.
Angle.
And this one, you might even have to know how to find an unknown angle. Like you might have to sum them all up.
Angle A or side A?
Oh, we're looking for side A, but before you can find side A, you got to find angle A. That's right. So I'm going to take that, but again, you're going to have all these models. It's up to you. I would find that sheet way too small. I would.
Yeah. Okay.
But if you're like some people are super small writers, you're one of those super small writers. You can do that. I like that one. Yes, sir.
I have this in.
Good. Now, which one of these do you need to keep in? That because it's what you're looking for.
Yeah.
And then,
But this is the whole thing.
good, so you want that. So which side do you not? Yeah, got it.
Yeah, okay.
That's right. Very good. Yes, sir.
Angle A.
Love it. Yep, very good. Very good. And so which one are you going to cut it? Perfect. Oh gosh, I'm going to cut it by lungs. Not working.
You don't.
No,
It's during
wow, that
science,
was dark.
so-
That was dark. And look both ways before I cross the street tonight, boy. Maybe you should do that every time you cross. But oh my kids.
And then you don't do it yourself.
That looks great. Yeah, and the number makes sense to me. Like it looks like a good number. Yeah, well done. That looks great. Yeah, that looks fantastic. How's that feel? All right?
Yes.
Yeah, not too bad. Does it ring? Because you probably did like a billion of these
Yeah,
last
we
year, right?
did so much.
So it does come back to you. Like, this is great. You're doing great work. What unit was there? Quickly we did. Okay, that works. Like what you're doing will work great. It's totally fine. The only problem with this is you find C. Cool. I want to find. Hey, you're doing good work. It's good. I'll take you. I love it. What do you know about all the angles? They have to. Remember a triangle with all the angles have to add up to? Yeah. Yep. So 81, 33, and then the last one, all together they add up to. Yeah, and it's always 180. So if you know they add up to 180, you can find the one you don't know, right? Yeah, that's good.
I just
Oh my.
Yeah, it's. Okay.
How you doing? Love it. Yeah, great job. You like that? Yeah, I like boxes too. But it doesn't matter. I don't. Yeah, that's great.
We're good.
Oh yeah. I don't expect you to just. Perfect. Yeah, that's great. Well done.
And you're cool with doing it all in one step.
Yeah, I'm gonna do it all in one step. As long as you do it right. That's the thing.
Okay. Well, I remember last year I kept getting yelled at, so just do it all in one step.
Well, yeah, I kept yelling at you because every once in a while you got it wrong. But as long as you get it right, like if you do that every time, cool.
Okay.
Perfect, great. So now you just have to cross multiply. Do that. So I'll give you a minute one. Do you mind putting that on here?
Oh, yeah.
Thank you. Yes. Are you way ahead of me? Are you all right?
So I got 30.
No, I'm gonna be mean now. I'm not here tonight.
That's mean, though.
Hold on.
Is that cancer?
Sorry?
Just be like, yeah.
Yeah.
Yeah,
Yeah.
that was perfect. Well done.
He's like,
You would just throw those in there.
you got 31.
Yeah, we did that yesterday.
Yeah,
So you're like,
yeah.
it's a curricular connection. See that?
We should hear you talking about it.
It made me so joyous.
Maybe
I
we should hear
downloaded
you
this
talking
worksheet, so I
about
stole
it.
this, and I
Yeah.
changed all the numbers to those, and I was so pleased with myself. Okay, I'm gonna make the units not matter.
Yeah, I realized that. I was like, that makes no sense. I was so mad, and I was like, oh.
And you can work in meters or centimeters, whichever one you like. They got a map.
That was good.
Nice, well done. All right, so let's take a look at this. Let's make sure we all are on the same page. So the first thing we had to do was figure out the missing angle, right? And we figured it out to be 66 degrees. Anyone, that's right, yeah? Nobody disagrees? Cool. And then we set up our sine law. And you'll note that she's just picked the two side pairs she needs, right? That to me is good thinking. At first, am I going to show like all this? Yeah, it's good practice. But when the push comes to shove, pick the side you're interested in and a side where you have both pieces of information and put them down. That's great. That's a good, yes, it's a shortcut. It's a smart shortcut. It's one that makes sense, saving room. And then the cross multiplying, yeah, sine 66 times 11. So that is the pair that doesn't touch what you're interested in. And we divide it by the remaining number, right? Simple cross multiplication question. And we get that side A is 10.2 inches. It was what, 10.18 or something? Perfect. Yeah, that's great. Well done. Does anyone have any questions about that? Don't be shy. We can go through. I could do 7 more examples if you want. I could make these up all day. But that's only one way to use this. We can do this, which is using sine law to find the length of an unknown side. What else could I use sine law to find? Yeah, we could use it to find the measure of an unknown angle. Okay. So here we are. And the first thing we're going to do is we're going to set up our sine law. And I would like us to see if we can be brave and pick just the appropriate pairs, just like last time. Can we try that? In other words, we're going to have a fraction equal to a fraction, right? Okay. The first thing we need to know, and I should say that like they used a lowercase m in here. And I left it. I took this question from your textbook, which ironically I'm not handing out to you because it sucks. But I took this question from your textbook, and at first I was like, oh, they used a lowercase letter for an angle. I'm going to change it. And then I thought, you're going to come across that. You're going to see people who do this wrong. So if we were going to label this, of course, we would call this angle big M, right?
Oh, I just did that at ABC.
Yeah, and if you want to call it ABC, go nuts. If I want to call mine, what are his initials again? If I want to call it like TAC, nothing wrong with that. That's fine. In which case, this would be side T, this would be side A, and that would be side C, right? Does it matter? No. What matters is, what do I want to know? Yeah, this angle in the corner. Whatever you call it doesn't matter. That's the angle I want to know. So if that's the angle I want to know, that pair has to be in there. So what's my first fraction got to be? What do you think?
8 over sine.
Very good. And again, what letter you use here doesn't matter. I'm going to put T because I like T, but the letter is complete irrelevance. Okay, what pair should I do next? Because if I do this, what am I going to put in that fraction? Bubkus, right? I don't know any numbers. So I can't pick that pair, so I've got to pick this pair. So what am I going to put here? Anyone? Very good. All right. Now, when we go to cross multiply, how am I going to cross multiply this one? And I'm going to stick with my highlighting theme because I like it. What pair do I highlight first? What pair am I multiplying? Yeah, what do you got? Very good. We're going to take 8 and multiply it by the sine of 75. And then what am I dividing it by? By 10. Good. Now, I want to be really careful here. What does that equal? What goes in front here? Yeah. Would it be right just to put a t out there? No, this isn't t. This is the sine of t. And this year I want to introduce you to something that maybe different teachers did differently, but I saw at least you do it the way that I prefer. What I'd like to do is this. If that's what sine t equals, well, let's look it up. Let's do this math first. We're going to do it this way once, but in the future, we're not going to do it this way. Let's do that math and see what we get. There we go. So what am I going to have to punch in here? Anyone? Anyone? Yep.
D equals inverse sine.
Okay, yeah, but you're totally right. But just for this one, as I have it set up, what am I going to punch into here? Yeah.
So 8
Yep.
times sin divided by that.
Great. And what do I need to make sure I do here? I need to make sure I close that bracket. And we're dividing it by 10. Very good. Okay. And so we get sine t is equal to what? 0.7727? Okay. Now, I want to quickly kind of say, before we remind ourselves how to use a certain button on the calculator, if the sine is 0.7727, remember sine is always this first column. Can we find that angle on this table or find a close angle to it? 7727. Where would I find that on here? Yeah, like 50 is too little and 51 is too big, right? So our angle is going to be somewhere between 50 degrees and 51 degrees. Does that make sense? Why do I make you do this? Because I think it's useful to remember that the sine is just another way of looking it up. Now, in 2018, nobody pulls out a sine table. When I was in high school, we had tables like this, only they went to 2 decimal places in the back of the textbook. It was like 12 pages at the back of your stupid textbook. And you'd go back there and you'd look these numbers up. and you'd punch them into your equations because the calculator couldn't do sine, cos, and tan at the time. And then later on, we got ones that could. But here, I just want to stress what we know is not angle t. We know the sine of angle t. So how we then find t is we have to look that up. And we look that up with something called the arc sine or the sine inverse. And the symbol for that on your calculator is, yeah, which, by the way, is really terrible symbology. I hate it, but that's okay. We have to use this. And when we do that, we should get a number between 50 and 51 if we've done all this right. Now, how do I get that sine -1? Will this do it? Have I done this right? Yeah, but that's what a lot of you will want to do. What did I do wrong? That's right. So you have to press the second function button, that yellow button there, then sine, and now I put it in. And that will give me the correct answer. By the way, did it reach our prediction? Is it between 50 and 51? Yeah, to one decimal place, what do we have? Don't forget to round. 6?
50.6.
Ah, 50.6. Got it. May I offer you some advice? I think it's easier that once you get to this stage, think of it this way. What we actually want to do is take the sine inverse of this whole thing. 8 times sine 75 and divide by 10. And just do that in one step on your calculator. You'll find that because you don't have to take that decimal place and punch it in again, you're less likely to make a mistake. Does that make sense? So let me show you how you would do that. May I? So let's go back in time. I'm going to erase what we have here. I'm going to say, if the sine of t is 8 times sine 75 divided by 10, then t is just going to be the inverse of 8 times sine 75 divided by 10. And just remember, anytime you're looking up an angle, you're going to use the inverse. Because the inverse means look this angle up. We know the sine, look up the angle. So anytime you're finding an angle, you're going to be using the inverse. And then how would I actually punch this into my calculator? We just have to use a bracket. All right? So that's the only thing that makes this a little tricky, is that we do end up with 2 brackets in the calculation. But with a bit of practice, it's not a big deal. How do I get the sine inverse again? Very good. So second function, then sine. And now what am I going to type in?
The interruption with the weather the way it is today, they have canceled all late buses. So please be advised that you need to catch your bus at the end of the day. There will be no late bus at 4:30, and we encourage all students to be careful on their way home. Just remember, sometimes see you and can't stop. So just please be very aware of crossing the street and hope everyone gets home safe and sound. See you tomorrow.
Which way should you look? Both ways. Okay, how do we punch this in? Oh, you could start that way. Based on what I have, 8 times sine 75. And what do I need to make sure I do here? Close the bracket, and then divide by 10. And then what do I need to do? Close the bracket. And there we go. Does that make sense? It takes a little bit more memory up front the first time, but once you get in the habit of doing that, because you don't have to enter that decimal again, you're just less likely to make a mistake punching it in. Cool. So again, oh, that's a highlighter. Tomorrow I won't be with you, which makes me sad. 55, what did we say, 55.6? Or 50.6?
You're going to be here tomorrow?
No, so I'm not going to be here tomorrow, but tomorrow, listen, oh, I got 3 minutes, let me take it. Tomorrow what I want from you is I'd like you to have gone through all the questions on all 3 of the lessons we've done so far. So that's free form for you, but I don't just want you to do it. I want you to check with one another. This is collaborative, all right? Talk to other people. Don't just have an answer. Make sure you have the right answer. And it's a good rule of thumb. If 8 of you all got the same answer, you're probably correct. If 12 of you got different answers, you're probably all screwed up. And maybe you have to say, hey, Orlando, none of us are getting question 9 right. We better go through that, right? So when I get here on Friday, I'd like you guys to be able to tell me what questions we need to take up, right? We all got question 8 wrong, Orlando. We got to do that one. But we all got question 7 right, so we can skip it. Does that make sense? Cool. Yes, ma'am.
Damn.
Damn.
What's that supposed to be? A 0?
Decameters. Decameters.
Oh, I thought you actually had a sponge thing. You're like, damn.
Guys, for those of you who have put the protractor on top of the box of protractors,
Oh, sponge.
I invite you to put the protractors in the box of protractors. Thank you. Thank you. We can make sure the calculators go back, the rulers go back, and do be very careful. Remember, schmucks like me who don't have snow tires on their car may unintentionally attempt to kill you today if you're on the road. So be careful. Sorry? Well, I don't mean that I'm going to try to kill you. I plan on driving very carefully, but just be aware that it's slippery out there. So please.
It hurts.
Just next.
She does it with force, so you're getting hurt by her instead of the car, which is better. It sucks.
It is-
Now you have a
it is
bruise
better.
on your stomach from her.
There's a guy, he's like on skis, he's behind the car, and he's going through this.
Here's the deal. That's awesome until you fall. That is kind of terrifying, but that is super cool. All right, guys, have a wonderful day. Be kind to one another. Don't do anything Kayla what to do.
Can you leave something else for me to do? Like tomorrow, like Thursday's worksheet, Friday's worksheet, all done.
Are you already done?
Yeah.
All right. And like all the questions from yesterday and the day before?
Yeah.
All the word problems? All right, I'll see what I can find for you.
Yeah.
Nice. Well, that's a good problem to have. I like that problem.
I never had that problem before. At least for me, just in case I'm done.
Yeah, you bet. I will leave some challenge questions for you.
I can just skip tomorrow.
No, don't skip. No, we are not going to skip. We are going to be non-skippers.